In this video, we are going to look at the problems in the Chapter 11, Section 3 slides. We're starting here. We've got this sample space, S equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're asked to find, and a single number is to be selected randomly. We want to find each of these probabilities given the events A, the selected number is odd, and B, the selected number is a multiple of 3. So the probability of B is the first one we want to find. The selected number is a multiple of 3. Well, we've got 3 multiples of 3 between 1 and 10. That's 3, 6, and 9. So the probability of B is 3/10. Now, the probability of A and B, that the selected number is odd and the selected number is a multiple of 3. There are 2 odd multiples of 3 here, 3 and 9. So the probability is 2/10 or 1/5. Finally, we are asked to find the probability of B given A. That is the probability that the selected number is a multiple of 3 given that it is odd. Well, we have 5 odd numbers and 2 of them are multiples of 3. So that probability sorry, I'm looking at the wrong thing here. That probability is going to be 2/5. Yeah. We can also write that as probability of A and B divided by the probability of A, which would be 1/2. Or 3/10, 2/10 over 5/10, 3/10 over 5/10, sorry. So that's again 3/5, 2/5, 2/10 over 5/10. There we go, that's better. Sorry. Moving on. Given a family with 2 children, find the probability of each event. Both are girls, given at least one is a girl. Well, if we're given that there is at least one girl, there are 3 possibilities for a family with 2 children to have at least one girl. You can have 2 girls, or a girl born first and a boy born second, or a boy born first and a girl born second. It's all one thing there, not 2. So in only one of these 3 cases, in only one of these 3 cases are both of the children girls. That's 1/3. Now we want the probability that both are girls, given that the older child is a girl. Okay, well, the sample space where the older child is a girl is just GG and GB. So the probability of 2 girls, given that the older is a girl, is 1/2. A single card is to be drawn from a standard 52 card deck. The sample space S has 52 elements. Find each of the following given the events. A, the selected card is a face card, and B, the selected card is black. First, we're looking for the probability of B, the probability that the card is black. Well, half the cards in the deck are black, so that's 1/2. Then we're looking for the probability that the selected card is black, given that it is a face card. Well, again, half of the face cards are black. We've got three face cards in each suit, the Jack, Queen, and King, and of the 4 suits, 2 are black, so that's going to be 6 out of 12, or 1/2. Now we're asked to use the results of parts A and B to determine whether events A and B are independent, and yes, they are independent. Because the probability of B and the probability of B given A are the same. Each year, Jackie adds to her book collection a number of new publications that she believes will be of lasting value and interest. She has categorized each of her 20 acquisitions for 2019 as hardcover or paperback and as fiction or nonfiction. The numbers of books in the various categories are shown in this table. If Jackie randomly chooses one of these 20 books, find the probability that it will be each of the following. First, the probability that it's hardcover. Well, we look at the row for hardcover. There are 8 of them, 8 out of 20. Which is 2/5. Now we want to know the probability that it's fiction given that it's hardcover. Well, there are 3 hardcover fiction books out of a total of 8. The probability of fiction given that it's hardcover is 3/8. The probability that it's hardcover and fiction there are 3 hardcover fiction books out of a total of 20 books. That's 3/20. The planets of our solar system are listed below in order of their average distance from the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Carrie must choose 2 planets to cover in her astronomy report. If she selects randomly, find the probability that the first one selected is closer to the sun than is Mars, and the second is closer to the sun than is Saturn. So first we want to know the probability that the first one she chooses is, at random, is closer to the sun than Mars. Well, there are 3 planets closer to the sun than Mars out of 8, so the probability that it is closer to the sun than Mars is 3/8. Next, we want to know the probability that the second is closer to the sun than is Saturn if the first one was closer to the sun than Mars. So now we're looking for the probability closer than Saturn given first was closer than Mars. Well, we don't have to look at the specific probabilities here. We can look at the row here and see, well, now there are 7 left. One of Mercury, Venus, and Earth is gone. And we are looking for planets that are closer than Saturn. There are 4 of them left and a total of 7 planets, so that's 2/7. Then the probability of the first being closer than Mars and the second closer than Saturn is 3/8 times 4/7. 2/7, 4/7. This should have been 4/7, not 2. Sorry about that, because we have 4 planets closer than Saturn now. Is 12 out of 56 or 6/28? Well, we can divide both of those by 4 to get 3. 56 over 4 is 14. 3/14. Sorry, paper doesn't want to come up. Carrie must again select 2 planets, but this time one is for an oral report and the other is for a written report, and they need not be distinct. Here, the same planet may be selected for both reports. Again, find the probability that if she selects randomly, the first is closer to the Sun than Mars, and the second is closer than Saturn. Well, here, it doesn't depend, the one with Saturn does not depend on the one with Mars. These are independent events because we replace whatever planet we pick back into the selection. So our probability of getting closer than Mars is still 3/8. But now the probability of picking one closer than Saturn is 5/8. So our probability is 15 out of 64. Single card is drawn from a 52-card deck. Let B denote the event that the card is black, and let D denote the event that the card is a diamond. Are events B and D independent? No, these are not independent. Because a diamond is not black, and no black card is a diamond. If we know that the card that we have chosen is black, we know for sure it's not a diamond, and vice versa. Are they mutually exclusive? Yes. They are mutually exclusive because we cannot draw a card that is both black and a diamond. Anne is drawing balls from an urn. There are 4 red balls, 2 blue balls, and 5 yellow balls. In the urn, she draws 3 balls without replacement. Find the probability that she gets red, yellow, and blue balls in that order. Okay, so first, her probability of choosing red, first there are how many balls? There are 4 plus 2 is 6 plus 5 is 11. 11 balls total. The probability that the first ball she chooses is red is 4 out of 11. Times the probability that the second ball she chooses is yellow is 5 out of 10, or 1/2. But we'll write it as 5 out of 10 for the moment. And then the probability that she chooses a blue ball third is 2 out of 9. Okay, now we can simplify this a little bit. Get rid of that, and that, and that. We're left with 4 out of 99. If 5 cards are drawn from a standard 52-card deck, find the probability that they are all hearts. Okay, so this gets a little more complicated. We want to know the probability of drawing 5 hearts from a 52-card deck. And the way to do that is figure out how many ways there are to draw 5 hearts, and then the total number of hands that we can draw. Now, I believe that we calculated the total number of hands that can be drawn in the previous chapter. I'm going to find that number. Here it is. There are a total of 2,598,960 different hands. And we need to know the number of hands that are all hearts. Well, the number of hands that are all hearts is going to be 13, choose 5. Okay, well, that's 13 factorial over 5 factorial times 8 factorial. Okay, so that's going to give us 13 times 12 times 11 times 10 times 9 divided by 5 times 4 times 3 times 2. Okay, that allows me to get rid of my 10 and my 12. So I've got 13 times 11 times 9. Grab a calculator. That's 1,287 hands that are all hearts. So this gives me 1,287 divided by 2,598,960 for our probability. I think we can simplify that a little bit, though not too much. We can divide that by 3 to get 400. Actually, we can divide both by 9, I think. Maybe not. We'll check that. Yeah, that denominator is not divisible by 9. But it is divisible by 13. It's divisible by 11. No. Okay, so we can divide the numerator and denominator by 39 to get 11 over 66,640. There's our probability. The local garage employs 2 mechanics, Ray and Tom. Your consumer club has found that Ray does twice as many jobs as Tom. Ray does a good job 3 out of 4 times, and Tom only does a good job 2 out of 5 times. If you take your car in for repairs, find the probability that a good job will be done. You have no say in the mechanic selected. Okay, so what we want to do here is first, we know that we can either get Tom or Ray, and 2/3 of the time we will get Tom, we will get Ray, since he does twice as many jobs as Tom, and our chances of getting a good job done when Ray is doing the work is 3/4, plus 1/3 times the probability that Tom does a good job is 2/5. Really hoping that we get Ray here, but even if we do, I'd rather go to a more reliable mechanic personally. 2/3 times 3/4 is 1/2. 1/2 times 3/5 is 2/15. Okay, so I'll change this to 30ths, and we've got 15 30ths plus 4 30ths gives us 19 30ths probability of having a good job done. The last question for this section. Rob is among 5 door prize winners at a holiday party. The 5 winners are asked to choose without looking from a bag that they are told contains 5 tokens. 4 of them redeemable for candy canes and 1 redeemable for a $100 gift certificate. Can Rob improve his chance of getting the gift certificate by drawing first among the 5 people? Well, we can do this by checking the probabilities involved. Obviously, if he goes first, probability that he draws the gift certificate is 1/5. But note that the probability of drawing the candy cane is 4/5. Okay, now if he goes second, the probability that the first person draws the candy cane is 4/5. But then the probability that Rob draws the gift certificate is 1/4. And 4/5 times 1/4 is 1/5. If he goes third, 4/5 probability that the first person draws a candy cane, 3/4 probability that the second person draws a candy cane, and 1/3 probability that Rob gets the gift certificate. Cancel, 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 1/5. You should be seeing a pattern here by now. If he goes fourth, you get 4/5 times 3/4 times 2/3 times 1/2. Cancel, 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 cancel. Again, probability is 1/5. Finally, if he goes fifth, you get 4/5 times 3/4 times 2/3 times 1/2 times 1. Because if everybody else chooses a candy cane, then certainly he's going to get the gift certificate. But the probability still comes out to 1/5, and it makes no difference which position he in which position he draws. He will always have a 1/5 chance of drawing the candy cane. That is it for this video. If you have any questions, please get in touch.